Good afternoon, ladies and gentlemen. I'm very happy to introduce you to our spotlight, Science and Society, that will throw you in an instant into one of the largest Arctic expeditions that have been carried out, the North Pole Drift Expedition MOSAiC, of which you've heard quite a bit. And we will look at recent phenomena that we investigate, what they mean to our current ability to create climate models, to run climate models that allow us to have scenarios of our present and future. And from there, we go to the question of how science takes an approach as our future that has to have some benchmarks with regard to our relationship to the atmosphere, to water, to temperature on Earth. And to do that and discuss this with you from the viewpoint of the Arctic Circle, I have the pleasure to introduce you to two important coordinators of these points that I've just made. Here's Markus Rex. He is a professor of atmospheric physics from Potsdam, and he works with me at the Alfred Wegener Institute. And he has been the coordinator and chief scientist of the MOSAiC expedition and will talk about some of the recent findings. And the other great coordinator here is Halldo, Þorgeirsson. And he has been always there to coordinate in a way these benchmarks, the balance that we have to find with atmosphere, with the planet and humanity. He has lived through many, many political negotiations from Paris to all kinds of COPs, and he is currently chair of Iceland's Climate Council. And so the two of them will have 15 minutes to bring forward their viewpoints, and then we discuss, the three of us together, the important perspective of people of the Arctic and how the Arctic is relevant to all of us and what benchmarks, what goals we'll have to defend for our future. Markus?
Thank you very much, Antje. Thank you for this very nice introduction to the important topic. Yeah, our MOSAiC expedition, dear ladies and gentlemen, a year frozen into the Arctic ice. It was an expedition to the epicenter of climate change, and I'm really speaking here on behalf of the fantastic team that carried out this MOSAiC expedition. It was the largest Arctic expedition of our time, probably ever, a truly international and multidisciplinary endeavor with 7 icebreakers and research vessels working together, making it possible with 450 people from 90 institutions being on board. And actually we had 37 different nationalities on board doing that expedition from all areas of Arctic system research. The expedition was successfully implemented 2019 to 2020, and I'm happy and proud that we can say that. It was successfully implemented despite the huge challenges from the pandemic that destroyed so many other things on our planet during that time. The data will become freely available for everybody on this planet after quality control at the end of 2022. To support our common and joint mission, the goal to explore the climate processes of the Central Arctic year-round. So we started the drift, the year-long drift, on the 4th of October in the Siberian Arctic. You will see a map later. And our first day on our home flow for the next year was at the same time the last day we could see the sun before the onset of the polar night. And then the long isolation of the drift when we were closely, firmly locked into the ice started. We were in the hands of nature. The drift follows then the natural movements of the ice, driven by unpredictable winds and currents. And is completely isolated, with the next people 1,000 kilometers away, out of range of the long-distance helicopters, and several months in the complete darkness of the polar night. I'm still impressed from the experiences we had there on the ice during the night. We used the time to build up our research camp, a research city, more than 100 tons of scientific equipment, several kilometers of power and data lines, and 70 kilowatts of electrical power installed on the ice to support the dozens of measurements that allow us to study the Central Arctic climate system better and to represent these processes better in our climate models. First of these observations were for the first time ever. We have worked through fierce storms, They destroy infrastructure on the ice due to ice movement, due to the storm itself, the power lines and the scientific instruments. The snowdrift really massively affects the visibility and makes it hard to work there on the ice, but they are at the same time scientifically extremely interesting features, and we were happy to work through these. As you know, the Central Arctic is polar bear territory. That means all our work on the sea ice had to be protected by very comprehensive polar bear protection measures, a staggered system of instruments, some looking with thermal infrared cameras at the horizon, and then tripwires, and at the last line of defense, the polar bear guard that accompanies every group that is out there on the ice. We didn't have to harm any polar bear, and that shows that our polar bear safety concept worked and was successful, and nobody was hurt by a polar bear on the other hand as well. By the way, everybody returned healthy and safely from the Arctic. And then the expedition went into summer, the great melt of summer. This is our lovely home flow for the year, the MOSAiC flow, now covered with these shades of blue and green and turquoise from the melt ponds, melting everywhere, liquid water everywhere, dripping and running water, the great melt of the Arctic summer. And we had wonderful days there during summer on the ice. We had lots of polar bear visits again during summer. For several weeks we had daily bear visits. Didn't make our work easier, but of course they are also wonderful to see those animals on the ice. By midsummer, 30th of July, just after midsummer, our flow reached with the transpolar ice drift the ice edge in the Fram Strait. It followed the drift corridor that we have had in mind and broke up under the influence of waves and swell, as all flows do. So that is the end of the natural life cycle of an Arctic ice flow, and we were able to measure on that flow until the very last day. Then we took everything back on board, and the flow broke up within 1 day. We headed north for our last task to study the freeze-up of the Arctic at the end of summer when the sun goes down, approaches the horizon again, and the freeze-up starts. We took a route north of Norway, and in that area we typically expect fairly thick, sometimes multi-annual ice. We went through huge stretches of open water, sometimes up to the horizon with the speed limit of Polarstern without any resistance from the ice. And at the North Pole itself, we found patches, pretty large patches of open water. So the great melt, the summer melt, is really impressive to see, and it's impressive to see how rapidly the ice is disappearing. Our last day on the flow was at the same time the first day when the polar night, the next polar night, is about to start with the lower edge of the sun just touching the horizon on the 20th of September 2020. We left the flow and sailed home. And we brought back a treasure of data, 150 terabytes of scientific data, over 30,000 samples from the atmosphere, the snow, the ice, the ocean, and the ecosystem. And that data will allow us to study that complex mechanics of the Arctic climate system much better and to represent it much better in our climate model. And that, of course, is data for probably years and maybe decades of scientific research. But I still want to show you some initial results, things we have already seen. We have really reached a new level in understanding the atmosphere-ice interaction, which is a key factor for regulating the Arctic climate system, the interaction between these two components. We have 41 key parameters measured the full year around, and you just see the representation of these 41 parameters. Parameters telling us, measuring the thermal structure of the atmosphere in high temporal and spatial resolution, the wind and the turbulence in it, the turbulence which transports the energy from the surface into the atmosphere, the microphysical and radiative properties of clouds in the air and how they are affected by aerosols, with all the aerosol properties measured. The atmospheric chemistry that produces those aerosols and how that atmospheric chemistry interacts with the ecosystem, and that is the pathway how the ecosystem affects processes high up in the atmosphere and therefore back the ice surface as well. We have measured all terms of the surface energy budget, and that closes the energy budget of the Arctic, and this is a treasure that really takes our understanding to a new level, and we have done that year-round throughout all the seasons of the Arctic. Coming to the Arctic sea ice, and here I really want to highlight one of the key findings and questions. IPCC, the most recent IPCC report, put forward. So what is the future of the Arctic sea ice? We have looked at the current state. What's the future? The Arctic ice, and that's a statement from the IPCC, is likely to be practically, the Arctic is likely to be practically sea ice free in September at least once before the middle of the century, under all scenarios that were considered in the report. That's a strong statement. And it immediately brings up that question, will that trigger a tipping point towards a self-sustained and irreversible disappearance and loss of the summer Arctic sea ice? Once the Arctic becomes ice-free in summer, the ocean takes up much more heat that could prevent melting as freezing in winter and suppress freezing in winter. So the next summer will then again become ice-free and so on and so on. So there is a potential for a self-sustained runaway track for the Arctic sea ice here. Let's look at summer first. Picture from that is pretty depressing, what we brought back from the expedition. The retreat of the ice in spring, in early summer, was faster than ever. You see the sea ice extent here. The gray area is the sea ice extent from previous decades, and the blue line is the previous minimum from 2012. But the retreat of the ice was faster in spring of the expedition than ever, and the reformation of the ice in fall was later and delayed, later than ever. In summer, the summer minimum was only for the second time below 4 million square kilometers, which is only half of the values we found in the 70s or 60s, with a continuous decrease of the summer minimum values here. So the sea ice is on a rapid track towards an ice-free summer in the Arctic. But what about winter? In winter, we found a strong ice growth, which partially offsets the increasing summer melt. And we have a multitude of new measurements to really characterize that ice growth in winter. The surface air temperature inversions, these strong inversions that we found, much stronger than our models represent. The thin snow, still thin, and you see measurements from the expedition here in the order of 20 to 30 centimeters only. The cold and fresh water, the strong radiative cooling from the surface, all these factors lead to substantial thermodynamic ice growth in winter, which is still more important than the dynamical growth of the ice from ice flows that move on top of each other. And that led to the fact that if you look at the freezing departure here, the blue, that's the uppermost water column, up to 20 to 30 meters deep, we have freezing temperatures. We have a huge reservoir of cold water still, and a negative ice formation feedback in winter, because if you have more open water, then the cold atmosphere, the cold conditions from the atmosphere make it deep into the water and lead to more freezing. That's a negative and stabilizing feedback. Result in an efficient reset during winter, and the ice extent will likely stabilize if our global warming stabilizes. It's likely not on a self-sustained runaway track yet, and that's the good news from winter. Another surprise we found, 20 years after the production of the ozone-depleting substances were phased out globally as a success of the Montreal Protocol, one of the most successful international treaties for environmental protection. 20 years later, we found the largest, the most dramatic Arctic stratospheric ozone loss so far observed at 15 to 20 kilometers above the ice. Within just a few weeks, we have seen that 95% of the ozone in the heart of the ozone layer up here was lost. And we have modeled that, and we have seen it's found by climate change. It's the result of a complex interaction between climate change and the remaining levels of ozone-depleting substances in the stratosphere. And we found that for the higher emission scenarios, those scenarios which would result in a global warming far above 2 degrees Celsius, Arctic ozone loss, which you can see here, is not going to recover until the end of the century, as everybody expects, but is perhaps even going to get worse, only for the low CO2 emission scenarios. And those are the scenarios which would limit global warming to 2 degrees Celsius. The Arctic ozone layer is going to recover as expected. And that actually was a surprise for us. We have used our expedition to communicate a lot about it. I think we have the potential to reach people who are interested in the adventure, and we can use that to educate people who are otherwise not so interested in climate topics, to educate them about the state of the climate system in the Arctic and about climate change. MOSAiC has been on the front pages of the New York Times, the Washington Post, and pretty much all major international media, certainly in Germany. German and English high-end documentaries were produced and have been aired or will be aired in 170 countries worldwide. And we have produced 3 books, an expedition report, a high-end photography book, and a youth book. And the expedition report here is currently translated into 5 languages. So I think we can reach the global community with what we have done there, and we can use that as a pathway to educate people about climate change. And why is it so essential to stay well below 2 degrees Celsius? I've shown you one example, and that's one motivation to protect the ozone layer. That's new to us, but we have much more important reasons than that. What you see here is a representation of the different tipping points in the climate system and the degree of warming when these tipping points are reached. And if you look at the 2-degree warming line here, that's the range of uncertainty for when these tipping points are triggered, and there are such important things like the disintegration of the Western Arctic ice sheet, Greenland ice sheet. The summer Arctic sea ice is here with the range of uncertainty here. But if we allow the warming to reach 2 degrees Celsius, we are in the middle of that minefield of tipping points out there. We don't know exactly at which point we are going to trigger any of these, because there is that range of uncertainty. But it is a minefield. And I don't know, is it such a good idea to walk deep into that minefield or to send our children or next generations deep into that minefield? If we reduce climate warming to 1.5 degrees Celsius, we just start to walk a little bit into that minefield. We stay mostly out of it. And that is the motivation why we really argue so intensely for limiting climate change to 1.5 degrees Celsius, or at most a few tenths of degrees Celsius above that. But we have to stay clear of those 2 degrees Celsius warming. What's next? We now really want to involve the indigenous communities. The EU-funded project Arctic Passion, coordinated by Avi, here has a goal to achieve Arctic observations together with the indigenous representatives to combine all forms of knowledge from the environmental monitoring towards finding solutions for the Arctic. And with that, I want to thank all MOSAiC participants, all teams who made that expedition possible, and the great teams we had on board, the most fantastic expedition team I have ever worked with. Thank you for your attention.
Thank you very much, Markus. And now, Halldo, if you can further deliberate on why 1.5 degrees makes a difference to humanity.
Thank you very much, Antje, and congratulations to the Alfred Wegener Institute and the partner institutions that achieved this. And this is hugely important, particularly in terms of both communicating but also absorbing the science. And there's nothing more powerful than actually being able to be in those places. And I'm sure that the impact of this expedition is just starting. It will have a greater impact. And I was asked to kind of help bridging this over to then the response to climate change. And I wanted to kind of start by bridging a little bit on the science itself. And you saw references to the Intergovernmental Panel on Climate Change, or the IPCC. And this is a hugely important foundation for decision-making in terms of global governance on climate. And it's difficult to overstate the importance of this. But as you think of the IPCC, it's important that you don't think just of science. It's a conversation between science and decision makers. And so all of the conclusions that are reached by the IPCC, the headline conclusions, such as the one just quoted here, actually have been adopted and agreed to by governments through consensus. So that's a very important bridge from science to decision making. Also on the IPCC, we have received the first phase of 4 phases by which we will receive the 6th comprehensive assessment from the Intergovernmental Panel. That was the first one on the physical science basis. But we are now very shortly going to be receiving 2 other installments from Working Group 2 on adaptation, How can we deal with the impacts? What were we learned in terms of building resilience? And working group 3 that looks at all of the solutions, the economic instruments, and the policy response. And then this will all be brought together in September into one synthesis, one narrative. So really an important bridge, because it's impossible for decision makers to understand all of the science. That's why this assessment is so critical. But there were two things I really wanted to share with you today, then building on to that. And one is to reflect with you really what is Glasgow. And there's been a lot of references to Glasgow at this conference, including by the First Minister of Scotland that spoke to us here earlier. But I think it's really important that we conceptualize Glasgow not as a meeting happening somewhere far away, but it's really a deadline. It's really a moment of truth. And it's a deadline built into the Paris Agreement. And the Paris Agreement itself is driven by its long-term objectives, but the strategic approach of the Paris Agreement is iterative. It's has built into it an internal rhythm of 5 years, and it's generally referred to as the ambition cycle. I don't want to go into the specific of it, but it's very clear that as we reach, we being human family basically, as we reach this first deadline, we're definitely falling behind. We're definitely in trouble, and that's something that we have to be brutally honest, because otherwise we are fooling ourselves. And one manifestation of that, for example, if we take the nationally determined contributions that are already on the table, and regrettably some of them are not yet on the table, including from the largest economies, they fall short. They're very far from where they need to be. So what does that mean? The challenge is building ambition. And that is what Glasgow is all about. But where does ambition come from? Ambition is something that needs to be built or is built at the national level. And therefore, I welcome the fact that there are now very difficult discussions and decisions being made in capitals all around the planet. And that, I welcome it, because that just means that people are getting serious about the choices that need to be made. Yes, it's challenging also to agree international agreements, and it's challenging to take them through your parliament and have them ratified, but that's a lot simpler than actually making the difficult decisions about choices on energy, for example. And some of them have surfaced in our conversation already as we've been together here. So, and one way this is manifested is, for example, in coalition negotiations, including in your host country here. The key points are the nexus between climate change and energy, where Iceland will be going in terms of moving, what kind of net zero economy Iceland will create. Australia, the list goes on. We've also heard how Glasgow is a deadline even in Washington, D.C., and I applaud you all over having brought Senator Whitehouse here. I think that was really helpful to hear how even the U.S. Senate is using this as a deadline to get one's house in order. So it's building ambition, it's about leadership, it's about building momentum. It is not about negotiations, and that's something that I think we really have to be clear on. I'm simplifying a bit, but basically everything that needs to be negotiated at the international level in the context of the governance of this, in terms of the treaty itself, has been negotiated already. So it's really about what governments bring to Glasgow. Apologies. I guess Paris is still in my mind. For those of you that don't know, I was quite involved with that wonderful moment. And this is why the onus is on all of us as we select our leaders, as we make choices. And leadership is not just coming from governments. Leadership is coming from corporations. Leadership is coming from investors, and that's a really important component of this. Smart money is moving away from the fossil fuel dreams. And we just have to realize that. There's a race now to the net zero economy, and to stay competitive in that future economy, which is going to be the only economy on offer for the future. So, if this is Glasgow, where do we need to be after Glasgow? And that's another, I think, a really important thing that we think through. What's our benchmark for success of Glasgow? And I will submit 3 criteria. And one of them relates to how much risk we are ready to take as a human family. And you saw 2 lines on Markus's, one of his slides about 1.5 and 2. And it's really important as we look at this, not as scientists, but as policymakers and decision makers, these are really lines in the sand or guardrails. And the 2 degrees is an absolute defense line. The real aspiration is to come as close as possible to 1.5. And therefore, think of 1.5 more as an indication or guardrail for what we're aiming for. And therefore, one of the things that Glasgow needs to do is to keep 1.5 alive. And I pick my words carefully here. It's unreasonable to expect Glasgow to secure 1.5. And that's what this next decade is going to be all about. And the rapid changes that are now starting. Second is that short-term national interests need to yield to long-term collective interests. And this is a hard challenge for political leadership, particularly if we look at it through the lens of the short election cycles. But this is what leadership now needs to be able to do. Lift itself over the temptation to speak to the moment and actually invest in the future we want. And the third one is in terms of expectation where we need to be after Glasgow is number 1, rebuild the unity of purpose that was achieved in Paris. And this was a rare moment of unity, and this is a hard moment for that. Let's be honest about this. One of the bases of the agreement in Paris, of course, was the axis of unity between China and the US that had been built with hard effort. But that has to come back. The Secretary General of the UN has called for this. Second, we need to rebuild the trust among the governments, because that's what will allow the political economy to be suitable for difficult choices to be made. And finally, we also need to rebuild faith in the process, in the intergovernment, that there is somebody in, I don't want to use the word control, because that's not what it is, that there is, that indeed is global governance that helps us on this journey, because it's going to be a long journey. We have to be honest. We are perilously close to the edge, but there is a path to avoid falling off that cliff. But that takes, as the IPCC put it, large, consistent steps in the right direction. Thank you.
Thank you very much, the two of you, for your input. I would just say for a moment that myself, Antje Boetius, director of the Alfred Wegener Institute for Polar and Marine Research, my background is biology. So I would like to add to our challenges at this point that the physical targets that we've discussed, the physical-chemical targets that we've discussed, how much CO2 greenhouse gas in the atmosphere, how much temperature benchmarks, in all of them is a huge role for life, nature, the environment. And as IPCC has also concluded that the Arctic region is warming twice or triple the speed of the other planetary regions. And as we all know, that Arctic life is special. It cannot go anywhere else. It can retreat a bit further north, but cannot jump, as some kids suggest. Kids sometimes suggest just wrap up all the polar bears on a ship and transport them to Antarctica. And no, they have to stay in the Arctic somewhere. So we also have to understand in those negotiations that all life is connected, and it absolutely matters if the environment for the beautiful life of the Arctic is no longer there. And so could you please, from your 2 points of view, can again clearly say how difficult it is to imagine and on what timeline to work towards 1.5 and how important it is? Maybe, Markus, you can reiterate the key points of the Arctic that are touched upon that question.
Yeah, I mean, we see the pace, the current pace, the rate of disappearance of Arctic sea ice. It's with ups and downs, it's a fairly linear decrease, and we can just extrapolate it and see what happens if we stay on the track we are on right now. Then the Arctic will become ice-free in just very few decades. And if it becomes ice-free in summer once, that will kill that ecosystem that is connected and tied to the ice. There's a very rich life in the ice, just under the ice, completely dependent on the ice, with microorganisms, which then are the food base for fish, which is the food base for the seals, and those are the food base for the polar bears. It's all connected. And we have been there on the ice, and we have seen what a wonderful environment it is. The ice structures look beautiful, and the rich life in the ice is just fascinating, and it's just sad if I imagine that my children may not be able to see that because we have destroyed it. And I think we still have a chance, we still have the time window to avoid that scenario. We see it, we are not on a runaway track. If we stabilize climate change, we can still save that Arctic ice.
Yeah. You've been a defender exactly of that point, 1.5 degrees, and can you say again why it matters for all people?
Yeah, but I think it's also, you started with reminding ourselves of the biological dimension of this. And that's something that I think is critically important now at this juncture for us. We have for too long separated biological diversity, which is the term that's used at the international level, a complicated term, from climate change. And that is not, we can't do that anymore. The key driver of loss of biodiversity is climate change. But so we need to transform our relationship to nature. And that is something that is also a moment of truth now. And this is why I think it will be really helpful as we think of this, not to separate the physical, the climate things from life. And one of the key challenges for us in actually reversing climate change is actually the food system. About 1/3 of all greenhouse gases are in one way or another connected to the food system, both the production, consumption, and disposal. And that food system is under threat, not just because of climate change, but also because of loss of biological diversity. So we can no longer afford thinking that biological diversity or life, basically, is just for the museums and for the parks. And it's not just about the loss of iconic species. That's important. It's really about the whole basis of life. And this is where I think it's so helpful to integrate our understanding, but it's also very key of the solutions. So a lot of the very promising climate solutions now are referred to as nature-based solutions, because they are actually working with nature rather than against nature.
The Glasgow meeting, the COP26, will have important points exactly as to that. There will be the question of how can we count on nature in withdrawing CO2 from the atmosphere. And the matter of how we account for the achievement that nature already has, the forests, the soils, the microbes in the sea, is already large. And there is a danger that we start double and triple accounting, which to me is a key point that will happen at Glasgow to discuss this and even negotiate that.
Clearly, and maybe I think it's also important also to convey some of the signs of hope that in terms of nature helping us. We know that half of the greenhouse gases have actually entered into the ocean water. And one of the key exciting points, at least for Iceland, is that at 1.5, there is still that hope that some of that would be reversed. And that is what really has to be championed, and you're right. As we work with nature, it's really important that we are honest and from the atmospheric perspective, not some bookkeeping.
Right, so Markus, as atmospheric scientist, can you probably say again, where do these large uncertainties come from that plague us with the Arctic and the climate models in the scenarios? Parallel to MOSAiC was, of course, terrestrial MOSAiC, which is also tackling the question of uncertainties, how much carbon will be actually emitted by nature because of warming already that is not properly accounted for. What are, in your views, the important points that we have to regard concerning atmospheric contributions and solutions?
Yeah, the point is that the Arctic climate system is not only extremely important for the climate system of the rest of the world, it directly affects weather and climate in North America, in Europe, in large parts of Asia, where a large fraction of mankind lives. It's also the area, that Arctic, where we don't understand climate change very well, because it's unique. It's an ice-covered ocean, and it's the only ice-covered ocean. There is a sea ice belt around Antarctica, but that disappears every summer. That's not the case in the Arctic, and therefore it is a unique system, and we have never been able to do research in that system throughout the full year, in winter, close to the North Pole. On that scale that we now have been able to do with MOSAiC. And therefore, there are many processes in the which are specific to that system between deep ocean, a very thin layer of ice, and then the atmosphere above it, which we don't understand very well and which are not well represented in our climate models. And that is the source of huge uncertainty, which is larger there, up there in the Arctic than for the rest of the world. And you mentioned just a second, MOSAiC. It affects very much the budget of the greenhouse gas budget of the Arctic land surfaces, whether they emit huge amounts of methane due to melt of permafrost, or whether they maintain some of their functions to be able to take out some of the CO2 from the atmosphere, which is the same problem everywhere in the world. If we damage our ecosystem functions in their function as taking out CO2 from the atmosphere, we have a double problem there. And therefore, it is so important that we link our studies from the Central Arctic with the land-based studies here in MOSAiC.
Yes, I'm also thinking the heat waves that are coming up north to the Arctic, so where we know, of course, that the amount, the concentration of greenhouse gases per square meter, they absolutely matter for the heat waves, and so the amount of methane and CO2 that we have in the Arctic Circle matters absolutely for the extremes. And there is uncertainty, of course, to cover what will that mean now with the interaction of land ice and the global temperature changes. But let me ask now a more difficult question. We are discussing here, we're coming together as Arctic Circle, and I love the symbol of the Arctic Circle with the idea, basically, we could see the Arctic as an entity. Where would we be, think about it for a moment, if we would do Arctic science as an Arctic continent, or negotiations as an Arctic continent, as an Arctic government? So I really would like us to focus for a moment on the speciality of that region that is hurt amongst maybe the small islands the most from climate change. How would we do science differently maybe if we would program science infrastructure and data sharing together? MOSAiC tried a little bit of that with China and Russia on the table and everything.
I think we tried to do as much as possible or to make progress on those aspects you just mentioned. We have never worked together in such an international collaborative effort than in MOSAiC, and we have never brought so many different disciplines together for doing Arctic science as if it would be a international governance activity. We have just done that from a collaboration of science because we are all driven by the common goal to better understand that system. And that has some long-standing effect. I think we have formed the community of Arctic scientists in a way that we think more internationally, at least as scientists, and that we think more interdisciplinary. I now know what a COP report is, and you absolutely know what that is, but I just learned about that through my collaboration with my ecosystem colleagues. And on the other hand, the ecosystem colleagues learned about eddy covariance measurements in the atmosphere. These things, we now have a common basis, and we can work much better together, and that is also across the national borders. And it would be fantastic if that would spread into other fields beyond science.
Where do you see blockades that need to be solved here?
Well, let's be honest. The Arctic region does not have sufficient impact globally, and many of the Arctic capitals are not in the Arctic, and that is something we really have to face. And there is growing attention in terms of global governance on the regional dimension. And that is something that, and there's going to be a citizens' assembly in Glasgow. So this is why I think this conversation is absolutely critical. And the Arctic voice needs to be much more heard. But at the end of the day, we are all people of the Arctic, in a sense. Everyone is affected. And this, for example, there's been in this platform here a very interesting conversation with small island developing states, because they are at the receiving end of melting. And so this is, I really feel that in the years to come, we can no longer rely purely on nation states in terms of governance. There has to be a much more inclusive global governance, much more focused if we are really going to be responding to the urgency that we should be doing.
So last short words, what do we need to achieve next?
Cut our carbon emissions. That's the most important thing, and that is also for the Arctic. It's the most important thing to use that time window we still have to save the Arctic sea ice. And then science maintains that international and interdisciplinary momentum that we have built up and carry it into the future and involve the indigenous population more in what we are doing.
And Halldo, what's your biggest hope?
Well, my hope is that we will start delivering and stop talking.